Hello students, in the previous class we have discussed what you mean by concept, rest and motion, and even we understood what actually the motion in one dimension is and what is motion in two dimension and three dimension. So in today's class let us discuss the concept of what you mean by distance and displacement, speed and velocity, acceleration and retardation. But remember, all these physical quantities are nothing but scalars and vectors. So with much wasting the time, let us come to our today's topic, what you mean by distance. First let us go with the concept of what you mean by distance. Usually this is not something which has been defined. Day to day life we will be doing all the physical concepts, whatever it is of our living things. It has been related to our all the living things. So among that, first let us discuss what is the concept of what you mean by distance. So first let us see the definition, so that later I give you an example that makes you to understand clearly what is the concept of distance is. So the first one is distance, the length of the path. The length of the path traversed by a body. A body may be of anything, it may be weak, it may be a vehicle or anything else. So what it is the body is doing? It's the length of a path traversed. It is covering some length in a form of a path. The length of the path traversed by a body is called the distance travelled by it. What it is? It is the distance travelled by it. It is covering some path. Understand? It is covering some path. It has some length by a body, which is a body in this case. Body may be we or you. It depends on the example what you have been taking. Understand? So the length is the distance is defined as the length of the path traversed by a body is called the distance travelled by it. And remember, the path may not be straight. Usually, always it doesn't mean that distance should be very much straight. It may be of curved also. So to make you to understand this path may not be straight or it is curved, you will understand it in the later part of the chapter. First, now let us go with an example what we are having. See, it's a very simple example what I have taken to make you to understand the concept of distance. That is nothing but always you will move from your home to school. Is it not? So everywhere you will be living in somewhere nearby a school. Some students live 15 kilometers away, some live 30 kilometers away. But overall, you are moving from your home to school. Just this is an example. Don't think it is in a practical way that the distance between home to school should be in kilometers. To our example, convenient, I will take some. Understand? So here, from home, think that from home to A. So you are reaching from home to school. So this is the length you have been passing. This is the path you have been traveling. That is, I have considered that OA to be one path and A to be is one path. So that you will be traveling to a school in this way. Now, this OA has some, for example, think that it has 40 meter of length. What it is? It has a 40 meter of length, and from AP you have what you mean by 30 meter of length. Understand? So when you are leaving home, for example, you reach this cross, there is some circle, you just think that to reach your circle, there is to reach your school. So from here home to circle you have reached, that contains a distance of how much? 40 meter. So from this circle to your school, it has how many meter? 30 meter. So you have been traveled a path here. So the length of the path, you have to calculate now the length of the path, what you have been traveled here. So now in this case, the total distance traveled by the boy. Let us consider a boy who is moving from home to school. So what it is reaching from OA first. OA plus it is AB. So what is the length of OA? Length of OA is nothing but how much? 40 meter. What is the length of AB? AB is how much? 30 meter. Therefore, it is how much? 40 plus 30 gives you 70 meter. So the length of the boy travelled from home to his school is nothing but how much? 70 meter. This 70 meter is nothing but what you mean by a distance. Did you understand the distance? Since we should know the one more thing about distance, It is a scalar quantity. What it is a? It is a scalar quantity. You already know what you mean by a scalar quantity. What do you mean by a scalar quantity? Scalar quantity, scalar is a physical quantity which has only magnitude but no direction. Even in this case, we have a magnitude. This 70 meter is nothing but what? It is a magnitude. Very important question they ask. Sometimes they may ask you to write what is it a scalar. They give you a set of physical quantities and ask you to separate it. Which are scalars and which are vectors. This is a very important ICSE question. Now, since distance has only magnitude, what it is a scalar quantity. And what is this? SI and CGS units. This is very important. Always they ask in your examination. So we should be knowing what is it SI and CGS. So SI you already know, you have studied in our first chapter, measurement and experimentation. What are SI is? System of international quantities or international system quantities. CGS is nothing but centimeter gram second. So what is the SI unit of distance? SI unit of distance is meter. What it is? Meter. It is denoted with small m. Then what is the CGS unit? CGS unit is nothing but centimeter. So it is denoted by small cm. Understood? The SI unit of distance is meter. The CGS unit is nothing but centimeter. Now one more thing. How do you denote distance? The distance is always denoted with the letter S. You know that? This always the distance is denoted with the letter. What you mean by S? So now, with knowing the concept of what you mean by distance, let us move to what you mean by displacement. So what is the displacement I have written here? The shortest distance from the initial to the final position of the body. What it is? It's the shortest distance. What you're traveling. The shortest distance from the initial to the final position of the body. Let me explain you what is the initial position and what is the final position here. Since you were at home in the morning, you are from home to school you are reaching, right? So what was your initial position? So your initial position was at home. What is your final position? Your final position is nothing but school. What it is? The shortest distance from the initial to the final position of the body is the magnitude of the displacement. Now let me ask you a question. Among this, I have consider these two parts. OA and AB is one part. This is one part. And OC and CB is also one more part. You have two parts here to travel from your home to school. Let me consider same thing. Here we have what you mean by 40 meter of distance and this is 30 meter of distance. Now can you see it is in a rectangular shape? We know that always in a rectangle opposite sides are equal. Obviously even the CB will be having 40 meter and OC also will be having 30 meter. If you go in any of the parts, the distance remains the same. That is 40 plus 30 70 meter, 30 plus 40 70 meter. But what actually the displacement is? The displacement is the shortest distance from the initial to the final position. Which do you think the shortest distance is? Either this or this? Just think over it. No, I just tell you that neither this nor this way is the shortest distance. The shortest distance between the initial and final position is this. You have understood what is the shortest distance among here? So shortest distance from your initial and final position is this. Now you are wondering how can we calculate this displacement? How can we find the magnitude of the displacement? See that in which shape it is. It is the shape of right angle triangle. Is it not? In a mathematics we have studied. This is how it is in the form of right angle triangle. If it is in the right angle triangle, how can we find out the hypotenuse? Yes, by using a famous mathematician Pythagoras Theorem. So by Pythagoras Theorem if you apply, this is nothing but OB square. Is it not? This is by Pythagoras Theorem. We have here OB square is equals to OA square. This is OA square plus how much it is? AB square. So Now how much is OA? OA is nothing but 40. This is 40 square plus how much is this? This is 30. Is it not? So how much is 40 square? Which is 1600 plus this is 900. 30 square is always 900. This is OB square. Now we have OB square is equals to how much is this? 2500. It is how much? 2500. But if you have square root in your LH side, if you shift towards it RHS, it becomes square root. So we have OB is equals to square root of 2500. What is the square root of 2500? It is nothing but 50 meters. Did you understand? Now what was your displacement in this case? Displacement is nothing but 50 meter. Now you might wonder what is the distance? Distance was how much? 70 meter. But what about your displacement? Displacement is 50 meter. Always remember, displacement will be always less than a distance. Understand? It can never be more than a distance. Why? Because displacement is the shortest distance. It is the shortest distance. It doesn't consider that always. In a case of distance, a body, how the body travels, we will calculate that way, that path to be the distance. But displacement is not like that. It is the displacement we consider. If a body is not moving also, we will consider that path to be a displacement. Why? That path will be the shortest distance. What it is? The shortest distance from the initial to the final position of the body. Now coming back to this, we have what is the displacement? Displacement is a vector quantity. What it is? Displacement is a vector quantity. What do you mean by a vector quantity? You know already, vector quantity means it should have both magnitude and direction. See here, already we have got what you mean by magnitude. What is the magnitude? 50 meter is the magnitude. One more thing we need to understand what it is. Along with the magnitude, we should also have what you mean by direction. So, let me explain you how the direction we get. I will be rubbing this so that you can copy. It is given in your textbook, this part. So, you know that how do we represent map in a geography, right? So, this side is considered to be north, this is south, and towards your right it is east, and towards your left it is south. And this position is nothing but it is northeast. What it is? Northeast, and this is southeast, and this is west. So we have this is southwest, and we have here what do you mean by northwest. Understand? See, this is how our mathematical representation depends. This is your north, this is your south, this is northeast, this is southeast, this is southwest, and this is northwest. Now come back to the definition what we have studied. See, the shortest distance from the initial to the final position of the body. We have found out already which is the shortest distance. Which is the shortest distance? The shortest distance is this. That is OB. Is the shortest distance. And position of the body is the magnitude of the displacement. Magnitude also we have found. What is the magnitude? OB is equals to 50 meter. We got the magnitude. Now what we need? And the direction from the initial to the final position of the body. How do we get the direction? Direction we should always see from an initial to the final position of the body. Here, how the body is being moving. This is the initial position, this is the final position. See, look, the body is moving in this direction, right? What is the direction here? According to the map, if this becomes north, south, this is east and west, it is moving like this. It is actually moving from southwest to northeast. You are understanding? So what is the direction? What is the direction of a body moving from home to school? That is the shortest distance from initial to final. That is northeast. So we have to write the displacement is a vector quantity. The direction is 50 meter towards northeast. Did you understand? So now we have both displacement and both direction. Hence displacement is a vector quantity. Understood? And there is one more thing. You always know the vector should be having a arrow mark upon it. The scalar, if you just write scalar is just, you can mention OB, but what about a vector? There should be an arrow mark above it. That gives you the meaning of what you mean by vector. Understand? So since vector is also a displacement is a vector quantity, we have this OB upon the arrow mark gives you the magnitude, and 50 meter towards northeast gives you the direction. Hence our displacement becomes a vector quantity. Now what is the SI and CGS unit in this case? The SI and CGS units in this case of what you mean displacement is same as that of what you mean by distance. I understand. What is it is also meter. SI unit of displacement is meter and CGS unit is also centimeter. So how do you denote a letter? Displacement can be denoted with the letter what you mean by S upon that arrow mark, since it is a vector quantity. Understood? So now after understanding the concept of what you mean by distance and displacement, still if you have any confusion, it will be eradicated now, because now we are explaining you what you mean of differences between distance and displacement. Then all the doubts what it been having, it will be cleared very much. Now we will see some of the differences between the distance and displacement. That makes you to clear the concept of what exactly the distance is, what exactly the displacement is. In the first one, let us look here. See, the magnitude of the displacement is either equal to or less than the distance. This is the first differences. So to make you to understand this one, I have considered some examples. See, in the entire distance and displacement, I have considered only one example. With the same example itself, I can make you to understand all the differences between that of distance and displacement very easily. See here, we know that already. This is a home and this is a school. And this is one part and this is the second part, and even this is the third part to travel from your home to school. Here, let us first find out which are the distances we have. First is distance 1. Means that is the first path, or even you can also consider path 1. So in this path 1, I know I am traveling in this way, that is OA plus AB. So here how much it is? 40 meter plus this is 30 meter, that is totally 70 meter. This is one part, and the distance I got is how much? 70 meter. Now I am traveling in second part. So that path is OC plus CB. Let me consider that to be path 2. Path 2 is OC plus this is CB. So we have OC is how much? 30 meter plus CB is 40 meter. Totally we got what you mean by 70 meter. This is the distance what I got from path 2. So one more path I have, which is the path. This is the path. Don't think here this is the shortest path and it is always a displacement. No, that is wrong. It can be even distance. Sometimes we will move from here to here itself by walking. Think that you are moving in this distance either by car or bike. Sometimes your parents are not there in home, so you need to travel by your own. So you go by from home to school by walking. Think that this is some shortcut path. Understand? So that the distance here is the path 3. The third path, what it is just OB. It is how much? It is 50 meter. So from the path 1 we came to know distance is how much? 70 meter. That is this. And the second path is this. That is also 70 meter. And the third path I have traveled is directly from O to B. That is how much? 50 meter. All these three are distances. What it is? Distances. Now in this situation, what will be the displacement? What is the displacement in this? Among three paths, if I take also, which is considered to be a displacement? Path 1 cannot be a displacement because it is how much? 70 meter. Path 2 cannot be a displacement because it is also 70 meter. But path 3 is how much? 50 meter. Means the shortest distance from initial to final position. So always displacement will be how much? 50 meters. That is the shortest path. Among these three paths, which was the shortest? This is the shortest. So the displacement is always a shortest path. It doesn't mean distance can never be the path of displacement. It can be. It is one among the paths. One among the three paths. OB is also a path. That also could be a distance. Understand? Now distances we have 70 meter and 50 meter. But displacement is only 50 meter because it is shortest. Now come back to the differences what we have here. The magnitude of the displacement is either equal. Look at here, which are the magnitudes of distances? We have 70 meter and 50 meter. What about the displacement? Displacement magnitude is 50 meter. It is matching this. It can be equal. Understand? The magnitude of displacement can be equal to the magnitude of distance, or it can be always less than a distance. Look at here, displacement is equal to a distance and it is always less than a distance. It can never be more than that of a distance. Did you understand what did you mean by? So always by this we came to know the magnitude of displacement can either be equal to that of distance, but it is always less than that of distance. It can never be more than that of a distance. Hope you have understood the first differences. You can copy the same thing in your notes so that make you to understand the concept clear. It is not there in your textbook. So the second difference, very important one, this is the displacement can be zero even if the distance is not zero. Now to make you to understand the concept, again I have taken the same example of home and school. Now first let us quickly find out what is the distance in this case. In this situation let us consider morning you have reached from home to school. Understand? Evening you are coming back from home to school back. So what is your distance at this time? So distance is nothing but morning you went like this, OA plus AB. Have you looking into the arrow marks? You are moving in this way. You were at school till evening, and from school you use this path to come back home. This path. Look at the arrow marks here. So that is plus BC plus what is the last one? That is CO. So total how much is the distance? 40 meter plus 30 meter plus 40 meter plus 30 meter. So total altogether how much it is? 40, 40, 80. 80 plus 70, 70 plus 40, 110 plus 30 is total 140 meter. This is the total distance travelled by you from morning to evening. That is from home to school and school to home back. Understood? But now what about the displacement in this case? What about the displacement? See, we already know that displacement is nothing but shortest distance between the initial and the final position. So this displacement is written with the formula, that is final position minus initial position. See, you are considering a situation here. What it is, your initial position was what? Home to school. I am telling you, you came back from school to home. So what was your initial position? Initial position also was home. The final position is also how much? It is also home. So your displacement is 0 minus 0 gives you 0. The displacement at this case is considered to be 0. I know that it is very hard to believe to you, but this is how we determine the concept of displacement in physics. That you understand. So distance means we need to calculate the entire thing. But what about the displacement? Displacement is nothing but a shortest distance between the initial and final position. See, before you were going from home to school, you was having some value. That's the shortest distance. That time displacement was not 0 because your initial position was different, final position was different. Initial position was school, home, final position was school. But at this time, at this present situation, what I am giving, both initial position is also home, final position is also home. Hence your displacement is how much? Displacement is 0. You are understanding? So therefore one more example I am going to take in order to understand displacement can be 0. It cannot be 0, but distance can be displacement can be 0. Displacement can be 0, but distance it cannot be 0. So in this example we have understood. We have displacement here. Distance is how much? 140 meter. Displacement is how much? 0 meter. So one more example. Earth revolving around the sun. We already know this. This is sun. In a elliptical orbit, the Earth is being revolving around the sun. Think this is Earth. Now Earth started its journey from here. You know that very well. It takes nearly 365.25 days to revolve around the sun. After 365.25 days, the Earth comes back to its same position. Now what may be its displacement? Yes, because its initial position was this, and after 365.25 days, it comes back to the same place. So its displacement is how much? 0. The displacement is nothing but 0. Why? The initial position and the final position is same. Have you understood the concept? But in this case, what is the distance? In this case, what is the distance? See, usually you will find easily the distance. But in this circular motion, how to find the distance? You know that very well. Circumference of a circle. What is the circumference of a circle? In the mathematics, you know that. So circumference of circle is given by 2 pi r. What it is? 2 pi r. Where r is the radius of the circle. By knowing the radius, we can easily find the distance in a circular orbit. Did you understand? Usually in circular orbit, we consider 2 pi r to find out the distance, and the displacement, no doubt, it is 0. I hope you have understood the second one also. That is, the displacement can be 0. But distance cannot be 0. Distance can never be 0. Displacement can even be 0. In the very first one, we came to know magnitude of displacement can be equal to distance, but not it can be more than a distance. It is always less than a distance. In the second one, we came to know the displacement can be 0 even if the distance is not 0. And the third one, last, we can have that distance is always positive. Remember, distance is always positive. But what about displacement? Displacement can be positive or negative depending upon the direction. To explain you this, I will use this. For example, you think this is your friend home. This is your friend home, and this is your home, and this is your school. So from your friend home to your home, you have nearly 50 meters. From your home to school, you have again 50 meters. So morning, what you did is you went from your home to school, then you came back to school to your friend home. At this scale, what is the distance? In this place, we have a distance. Distance how much? 50 plus 50. No. So see here, from home to school we have 50. Again you are moving to your friend home. Before moving friend home, you are coming in the same path, right? Again from school to home you have how much? We have 50 meters. Again from your home you are reached to your friend home. That is also 50 meters. So totally we have 150 meters of your distance. So that is what? Positive. Distance is positive. But now let me see what is the displacement. Look at here. Displacement is starting you are leaving your home. Means your displacement was initial position is how much? Is 0 centimeter. Sorry, 0 meter. You can consider. So here you left 250. You are understanding? You left your home to school and reached 50 meter. Again you came back to home. Then your displacement became 0. Why? Your initial position and final position is 0. But you didn't stop to your home. In case you suddenly went to your friend home, therefore the displacement is how much now? Final position was how much? Minus 50 meter. It is how much? Displacement is, final position is minus 50 meter. Therefore the displacement is minus 50 meter. So by this example we can understand that distance is always positive, but displacement can be positive or negative depending upon the situation. In this example we have seen displacement is positive. In this example we came to know displacement is 0. In this example we came to know displacement is negative. Did you understand? Therefore distance is always positive. Displacement can be positive or 0 or negative. Did you understand the complete concept of displacement? If still you have doubts, you can go with textbook or be free enough to ask me the doubts.